Okay, let's start. So we already studied about the introduction, why we have to study electrical circuits, and what are the chapters, and what are the assessment methods. We already studied in last class. Now directly we start from the chapter 1, basic concepts. Okay, now, so what is an electrical circuit? So an electrical circuit is an interconnection of electrical elements. So elements we'll study in future classes. Like elements already you know what is a resistor, what is a wire, and a capacitor, inductor, power, battery, power source. These are all are called elements. So the interconnection means JAMA. The connection joining is called the electrical circuit. For example, in this what you observe? What are the items I have? Elements. I told electrical elements. So one is battery, is electrical element, which will give the voltage current, right? And this is a lamp. Okay, this is a lamp. This is called resistor also we can say, which will give the light. Okay. Now there is a two another things are there. The wires. This is one silk and tani silk. Two silks. Okay. So with the two silks means two wires, we connecting the battery to the lamp. So this is a simple electrical circuit. A simple electrical circuit shown in figure consists of three basic elements: battery, lamp, and a connecting wires. So item mojo. Three items. We are making a simple circuit. Now let us take a big and complex circuits. Here, this is a very complex circuit and very big circuit. What it having? Electric microphone, the speaker. It will give the sound easy, right? Now the resistor R1, R2, R3, R4. These are resistors. R3 and R4. Total 7 resistors are there. Now we have elements called capacitor C1, C2, C3, C4, and C4 is variable. We can change the capacitor value, variable capacitor, and C5 comes a capacitor. Now we have inductor L1. This is called inductance. We'll study all in the future topics. What is inductor? What is capacitor? And we have a transistor. This we'll study in the semiconductor madda. Transistor 1, transistor 2, Q1, Q2, NPN, PNP transistor will be there. Now here we'll give the DC supply of the battery 9 volts. Now here antenna from where we catch the signal. So this is a complex circuit. A complicated real circuit is displayed in this figure, representing the schematic diagram for radio receiver. This is for the radio receiver. Okay, we have big radio receiver in the home, right? We get the news, we get the Quran, right? That's one we'll cut. So simple. This is a main circuit. Now come to our first topic. First topic in the electrical circuit. What is the charge? Means what is the charge? Definition of the charge and current. Then we'll study voltage. Then we'll study power. Okay. Well, today we'll finish charge and current in short. So charge Q is denoted in the small q. We have two different denotation, Sagir huruf and Kabir huruf. Small q is the charge and capital Q is in the different way that will come into the next. So charge small q is an electrical property of an atomic particle of which matter consists, measured in coulombs. Means the smallest value, Sagir value inside of each molecule we have a charge. Okay. Each molecule in each material we have a electrical property. Means inside we have some electrons. That electrons consist of a charge. Okay. So it is a electrical property. Means electrical property means which can transfer or which can absorb energy. Electrical property. So atomic particle, automatic. So atoms. Our bodies consist of many atoms. Any material in the world consists of atoms. So that atoms will have electrons, protons, neutrons. That electron is nothing, gives a charge. So it is measured in the coulombs. So we will see that one. The charge of a single electron means in the Wahid atom, many electrons will be there, right? Many electrons will be there. Valency band, we'll study in the physics. So many electrons will be there for each atom. So the charge of each electron means Wahid electron will give some charge small q. This is a small q. Or a portion is known as elementary charge. Means small q is produced by each electron is nothing but a charge. The electron what it gives is nothing but a charge. So and it is denoted by lowercase e. So the charge of electron means small e. This is Sagir e, the electron. So how much charge this electron will have is, we'll see that one. So the proton have a charge of positive and electron have a negative. That is plus E means the proton. Minus E means the electron. Minus always is for electron. Positive is for proton. So the coulomb is a large unit of a charge. The coulomb is a large unit of a charge, and in 1 coulomb means Wahid coulomb of charge there are 1 by 1.602 into 10 power minus 19 electrons, means 6.24 into 10 power 18, means in Wahid coulomb we have how many electrons? 10 power 18 electrons. Means Ashra power 3 come Mia, Ashra power Talata come Alf. Like this, Ashra power hada Tamantash mojud. 10 power 18, very, very huge value. That many what we call electrons are there in 1 coulomb of charge, and that is denoted by capital Q. Okay, this is small q. Small q is electrical property of electron, that is 1.602 10 power minus 19. But if you say 1 coulomb, then how many electrons? 10 power 18 electrons will come in 1 coulomb. It is a bigger, large quantity. This is called large quantity, and this is called small quantity. Now, in the labs, generally, one typically sees picocoulombs, nanocoulombs, and microcoulombs. What is micro, nano, and pico? Micro means 10 power minus 6. Sagir value, 10 power minus 6. Okay, to milli 10 power minus 3. Micro 10 power minus 6. Milli means what? Wahid taqsim alf. Hada milli. Wahid taqsim hada itnain alf. Means alf zarb alf. Hada micro. So like this we have nano 10 power of minus 9. Pico 10 power of minus 12. So these small values will get in the coulombs. Okay, charge is always multiple of electron charge. Now generally we know nus charge, half charge, we don't have any like that. We have multiple, means wahid coulomb, ithnain coulomb, talata coulomb, like this only, not nus, ithnain nus, talata nus, nus maafi mojud. Means this is called 2e electrons, are that is minus wahid charge, that is minus 1 electron, minus plus 2 electron charge. This is minus plus 2 electron charge means 2 protons, 2 proton charge. It is 1 proton electron charge. Minus 2 electron charge, but not like nus or 0.3. There is no fasla in this one. This is multiple, means 2, 3, 4, 5, multiple only. Charge cannot be created or destroyed, only transferred. The charge is cannot be destroyed or cannot be created, just only transferred. Means the world is make all the with the atoms only. So that cannot be destroyed. Only it can be transferred the charge, that electrons will transfer from one place to other place, and that will give the charge. Now if you see here, the charge of a single electron or a proton is known as elementary charge as per the definition. So charge of a single electron means wahid electron come charge hada come coulombs minus 1.6. It is the symbol hada because electron hada minus Eg, and 1.6 multiplied by 10 power minus 19. 10 power minus 19, very sagir value is known by 1 electron. Wahid electron will give the this much coulombs. Here I told you here. What told you? Pico coulombs, nano coulombs, micro coulomb means 10 power minus sita, minus tissa, minus itnash. But here come mojud minus tissatash mojud means minus 19. Very, very small value. That much coulombs only is given by the 1 electron. Means to give some value of the charge, how many electrons we need? We need many thousands, millions of electrons will give 1 coulomb of charge. How many? 10 power of 18 electrons will give 1 coulomb of charge. Kam electron lazim? 10 power 18 electron jama zarb is will give wahid coulomb charge. So that is important. So if you see wahid coulomb, the same thing. Wahid coulomb charge is 6.24 into 10 power of 18 electrons. 1 electron come hada 1.6 on 10 power minus 19 coulombs. Just reverse. Aksada. So this is about the charge. Any doubts? Charge always is a elementary part, means it based upon the atoms. In the atoms, the electrons or protons what we have, it will develop a charge, and one charge is one electron charge is given as 1.62 in 10 power of minus 19 coulombs. And 1 coulomb is equal to how many electrons? 6.24 into 10 power of 18 electrons. 1 coulomb is equal to. So it is measured in the coulomb. Charge is measured in the coulombs. Now coming to the current. So electric current is the time rate of change of charge. So once you know what is the charge means, it's an electron. Basically, it's electron. Charge means, okay. The time rate of change of the charge means electron movement. Electron is coming to charge. Now a charge, when I move it with time, means wahid dagiga kam, ikran dagiga kam, or wahid taniya kam. So the jama is called current. The zarb is called current. Means when wahid taniya, let's take ashra coulombs. So ashra coulombs zarb wahid taniya is called current. It's called current. Charge multiplied by time is nothing but current. So that's why it's called electric current is the time rate of change of current. Means by the time how much it is changing. 1 second x, 2 second 2x, 3 second 3x. Like this, how much it is changing. So that is called current and measured in the ampere. These units are very, very important. Charge measured in coulombs, C, capital C. Current measured in amperes, capital A. Voltage measured in volts, capital V. Resistance, ohms. So like this, units you have to remember, and wherever you write the equation or solve the problem, jumbo on the side, you have to write the unit A, C, V. You have to write it. Without writing, it doesn't mean anything. 0 marks for that. Because without unit, how can I know this is a current, this is a voltage? How I know? So the scientists say unit must write. So the current is nothing but is a time rate of, the electric current is the time rate of charge, change of charge measured in amperes. Now see here this diagram. When the battery is connected with the plus and minus terminal, the electrons will move to the positive terminal, right? And the conventional current is the opposite. We'll see that one. Okay, mathematically the relationship between current I, generally I, small I is the elementary current, and charge Q, the elementary charge Q, and time t is given as I is proportionality equal to dq by dt, rate of change of charge, rate of change of time, rate of change of charge, dq by dt. dq is varying with the time. So how much it is varying with the time, it is called time rate of change of charge. Where current is measured in amperes, and 1 ampere is equal to wahid q. 1 ampere, the wahid ampere is equal to q by t. Q is measured in coulombs. The same time is measured in seconds, taniya. So wahid coulomb per second. So it is 1 ampere is equal to 1 coulomb per second. So if you remember this, if in exam or in question something like it is there, 5 coulombs is I have for 10 seconds. How much is the current? So 5 multiplied by 10, 50 amperes is the current, like that. Okay, so we will see that one now. Now the charge transferred between time t0 to t. Now let us take, I want q, this q I want, then dt you have to take this side, this dq will become integration, this become integration. The same equation I just rearrange, I change I dt here. So I dt here, that is I dt, right? Now dq, now dq will become capital Q, because we are calculating in the combined way from one time to other time, t0 to t, t0 to t, initial time to some t. So the charge transferred between time t0 to t is, from t0 to t is integration of I dt, integration of I dt. Okay, so what is the meaning of small q and capital Q is difference? Because already you got it here, small q, here you got capital Q. What is the meaning, right? So here, small q is nothing but source charge, often large or fixed. So source charge means from here, from the source, from where it is delivering, the source charge in the big way, in the big way. The charge that creates an electric field means the battery always creates an electric field because it has a potential power it has. So it creates electric field. We generally measures in capital Q, source charge, means on the bigger picture. Now small q is a test charge, test charge, usually smaller or mobile, means it's moving, means how many electrons are moving here, that is called test charge, small q. The charge that is affected by the field, due to this field how much electrons are moving? Wahid electron, Tani electron, how moving? That is comes in the Q, small q. So these are the two different name pictures. Capital Q is for source charge in the bigger picture. Small q is the test charge. When we apply the field, how much electrons are moving? That is called small q will come. Okay. Now, when a conducting wire is connected to a battery, so to this battery there is a wire is connected here. This is the conductor. This is the conductor, and wire is connected to the battery. And the charge are forced to move, means the charge inside this conductor, that is electrons. Electrons. Negative means electrons. Negative electrons. Positive means protons. Right. So these negative electrons will move this side. Moves in the direction. Okay. The positive charges move in one direction, while the negative charges move in the opposite direction. So positive charges will go in this direction, and these negative charges will go in this direction. So this is when you connect a battery with a electric wire. So in the wire, the electrons will move because of the electric field of the battery. Yeah. After the chapter only we'll send. You have to listen first. Only just what I'm telling and you are reading is not important. First you have to understand what I'm telling. That's important here. Okay. After the chapter is finished, I will send it. Later we have discussion. So, okay, here some problem is there. Here some problem is there. You can ask questions. Okay. So every time what happens when I send the notes, you'll open the notes and you'll read it. Okay, Doctor is okay. He is reading this. I am also reading this. No, that is not this. You have to listen me and understand. Then read at home. Then it will be easy to memorize, not directly in the class. Okay, when you connect a conducting wire like copper or to a battery, same thing I am explaining in another way. This is one way, in another way. This is two ways. When you connect a conducting wire like copper or to a battery, you are creating a closed circuit. Means we are completing the circuit. Closed circuit means we are completing a circuit. Then this allows electric charges to move, and that movement is we call electric current. So when you connect a wire to a battery, then what happens? It form a closed circuit. Means it finishes a circuit, no gap. There is no open. There is a closed one. So when there is a closed one, due to the battery, the voltage, what happens? The electrons forced. The electrons pushed. Okay, you have to move from this place to other place. Then that movement is nothing but a current. Okay, due to that force of the battery voltage, inside there is a huge source. Capital Q is there. Capital Q is there. That one will force the battery field, will force the electrons to move from one place to another place. It's nothing but inside the circuit only. So that is movement is nothing but the movement is what is called electric current. Electric current is basically movement of a charge from one place to other place. Okay, now coming to the charge and current. Okay, there are two types of current. Now we know what is a current. What is a current? It is a time rate of change of charge, right? So what are the different types in the current? So one is called direct current. A direct current is DC, we'll call direct current, short form, is a current that remains constant with time. Remains constant with time. Means electrons are moving, but in a particular time, that many electrons only move. It will not change. From X electrons are moving from 1 second. Means for 30 seconds, the same electrons will move. It will not change. Here, the charge moves only in one direction. Means the charge will start from one point to other point. It will go in one direction. Let us take like this, anti-clockwise. Then it will move in that direction only. That is called DC. If the charge is moving for one taniya in positive direction and taniya negative direction, positive direction, negative direction, then it is called alternating charge. That is called alternating current. AC, alternate means one wahid second, mumkin wahid second example I am telling. For wahid time, it will move in one direction. In tiny time, it will move in another direction. That is called your alternating current. So alternating current, AC generally we call, is a current that varies sinusoidally with time. Now here there is a way. How this sinusoidal? How sine wave did you see in the maths and physics? Sine will be go up maximum and go to 0, come down negative maximum and coming to the 0, the sine wave, right? Sine wave. So in this fashion, if it is go, it is called alternating current with a sinusoidal fashion. Okay. So here the charges move into two directions. They oscillate back and forth. Means oscillate, go back and forth, front and back, front and going back. So we'll see in the diagram. See the diagram. Okay. During the positive half cycle, electrons move in one direction. Positive half cycle. In negative half cycle, electrons will go in another direction. During the negative half cycle, they reverse the and move in the opposite direction. See here. So this back and forth motion happens many times per second. In Wahed Thaniya, many times it happens. So that is called depending on the frequency of AC, means how your generator is designed. Because battery always constant charge, means direct current charge. Direct current you call. Generators will give the alternating current where frequency will come, means as per the design of the generator, how many times, how many cycles in Wahed second, in Wahed Thaniya comes cycle, means 0 to maximum, maximum to 0. 0 to negative maximum to 0. It's called Wahed cycle. So in Wahed Thaniya, kam marra hada iji. So how many times it completes the cycle is called frequency. Means frequent. How frequent we are moving. If we go out and come in, again go out and come in, again go out and come in. In 1 second, how many times you go out and come in is called frequency. Okay, in 1 second, if you say 2 times you go and come, then it's called a frequency. Means how frequent it is. Okay, in Saudi Arabia, for example, the standard frequency is 50 Hz. This is 60 Hz we have. In India, it is 50. It is 60 Hz. Means in Wahed Thaniya, 16 marra the positive negative will come. In 1 second, see how fast it is. So this is all our AC only. So in 1 second, the light is going to 0, dark, off, and maximum. Again off, going to negative maximum. Again off. How many times? 60 times in 1 second. So can you observe that one? Off, on, off, on, off, on. No, because our eye has the limitation. That is only Ashra Marra can see. In 1 second, if it is on and off for 10 times, okay, you can see that one, not more than that. It is 60 times, so it look like a constant. It is a AC, but it look like a constant only because our eye can't see. Devices, if we connect a device, oscilloscope we call, there you can see that 0 to maximum, 0, negative maximum to 0. So like that. So see now here, this is your direct current and this is your AC. So direct current is always constant, means for a period of time, the current moves same value. Current will be constant, not changing for a period of time. Now, for this, for a period of time, the current is moving from 0 to maximum, maximum to 0, then 0 to negative maximum to 0, and again repeats. This from 0 to this 0 and again 0. The second 0 from above 0 to the first and second 0 is called a cycle. In this, one is positive, one is negative. The two joined together is called one cycle. Okay. So like this, how many cycles we have in Saudi Arabian power supply? We have 60. Here the kata is there. 60 hertz is the unit is hertz, means frequency, hertz, means 60 times in 1 second. So this is about the, okay. Now direction of current. How the direction of current is there? Now I said it is a positive and you are negative in AC, in DC, constant you are telling, but that is called movement of charge, that is. Okay. Now the current, how it is defined. The conventional direction of current flow in electric circuit is from the positive terminal of battery towards the negative terminal. Now I told you that when you connect a battery to a conductor, closed circuit, the negative electrons will move towards positive direction, means towards the positive terminal of the battery. That is, electrons will move, the charge will move. But we, conventional current for analysis, we use the current as a positive to negative in opposite direction. We move as the force. Due to the force, the positive to negative, it will move as a current. But inside the wire, that is opposite. Outside the wire, we use it like that. Inside the wire, opposite. Electrons will move from towards positive terminal, in opposite to the current. That is I, conventional current. Now we'll see here. You will get confused here, don't worry. Inside the wire, what's happening? Outside the wire, what's happening? Check. Inside the wire, electrons are the mobile charge carriers. The electrons will carry the charge. What is how much one electron will carry the charge? Just I told you. Wahid electron come charge 1.62 into 10 power minus 19, right? So that much charge it will carry. How it will carry from where to where? It will carry inside the conductor and towards the positive terminal. It will go towards the positive terminal inside the conductor. Okay. They move from negative terminal, that is where there is a surplus of the electrons. So at the negative terminal, there are huge electrons will be there. From there, they will be pushed. They will be just pushed from that point, negative terminal of that battery or a source to positive terminal of the battery in the silk, in the wire. In the wire, what happens? The electrons will move from negative terminal where there is a surplus of electrons. Because the field from where it is coming, the force where it is coming from the battery, it has very potential, very huge amount. From where it is coming, negative electrons. What is electrons? Negative charge, right or wrong? Electron means minus E, negative charge, right? So negative charge where it will be? In minus terminal, right? From that minus terminal, they are pushed. So it will move from minus terminal to plus terminal inside the wire, inside the silk. Okay, now, but we draw current arrow, but we draw the current arrow from positive to negative following the conventional rule. So the scientists may generally will that we always go positive angle or positive direction. Our thinking or our calculation should be there. Inside wire it is happening in opposite, but positive to negative generally we have a direction. They form like that. It's not actual. Actual is inside negative to positive only electrons moving. But conventional current, what scientists decided to just note the direction of the current should be from positive to a negative terminal in the circuit. Okay, like this. So plus and minus is the battery. Then the current will, the conventional current outside the wire I am telling. This is outside the wire, conventional, what we denote, what we write. But what exactly happening inside the conductor is this one. This one moving from negative terminal to positive terminal inside wire. The electrons will move from negative terminal to positive terminal. But in the general schematic, in the general diagram, conventional current we call it. That's why we call not normal current. We call it as a conventional current. Actual current is from negative to positive. But conventional current means denotion of current means denoting how we denote it is positive to negative like this. Positive to negative we call it. Okay. Okay. So if you want, I can open this. Okay, this I will open, no problem. Okay, now coming to the one. Okay, direction of current, same thing. How will you denote? Now, if you see here, what you observe here? This is a silk wire. I denote that 5 ampere current is from down to upward. Now here minus 5 amperes of current is from up to downwards. Or these two are different or same? I mentioned here that there is a current moving from down to upwards in this wire 5 amperes. Now in this wire 5 amperes minus 5 amperes current is moving from up to down. Both are same or no? Check. Okay, no. 5 amperes moving 5 plus 5 this is plus 5 amperes moving upwards. Okay, forget about the direction. 5 amperes. Let's take here the positive terminal, here the negative terminal. Then what happens? Electrons will move from negative to positive, right? Okay, if I have minus 5 amperes, same positive terminal and negative terminal. So electrons will move from where? Minus 5. So it moved from the same negative terminal to the positive terminal. Means here due to the sign is changing and direction is also changing. Sign also changing, direction also changing. So both are same. It means both are same. Check here. A negative current of minus 5 amperes flowing in one direction. Negative current I am telling. Negative means Negative current means what? The electrons, how it is, they are flowing from positive to negative. Electrons flowing positive to negative. Now, positive current 5 amperes, how they are flowing? Negative to positive. Okay, so the direction is same. Because they are moving negative to positive and positive to negative, the wire is same. Wire is not changing. I am not changing the wire, but I am changing the direction of the current and the sign. So both are same, I am telling. So it's same as the positive ampere, 5 ampere flowing in the opposite direction. These two are in the same orientation, it means. Okay, one example, 3 examples are there, problems. How much charge is represented by 4,600 electrons? Arbal, Sita, Mia, electrons mojud. So why the electron come charge? Why the electron come charge? 1.6 into 10 power minus 19. Why the electron? So Arbal, Sita, Mia, electrons come charge? Just Zarbhada. Just Zarbhada, you will get the total charge. Okay, so it is 1.60 minus, electron means minus. So minus 1.60 to 10 power of minus 19 Zarb Arbal Sitamia electrons. It will give minus 7369 10 power of minus 16 coulombs. So this is how we calculate. Why the electron come charge and number of electron. Zarb will get the total charge. The total charge entering a terminal Q is 5t sin 4 pi t millicoulombs. Millicoulomb. Milli means 10 power minus 3 millicoulomb. Calculate the current at t is equal to 0.5 second. Now, at t is equal to 0.5 second. Current I. I is equal to what is the equation? dq by dt. Differentiation dq by dt you will get. So here I equal to dq by dt. So we have d times 5, put it, what is q? 5t sin 4 pi t. 5t sin 4 pi t divided by dt. Now, if we differentiate, there are two terms are there, a and b terms are there. T is there and sin is there, ab. Differentiation of ab. What is the differentiation of ab? d by dt of ab. A multiplied by b is there. What is the differentiation? First differentiate a, keep it b as it is. Plus differentiate b, keep a as it is, or differentiate a, keep b as it is first, plus differentiate b and keep a as it is. So first one, I am differentiating t, d by dt. What is the differentiation? 1. So it will become, t will become 1. 5 sin 4 pi t. 5 sin 4 pi t. Okay. Now that is a part. B part. What is the b part in this? Sin 4 pi t. This is the b part. A is t and b is this, sin 4 pi t. 3 t terms mojud. So sin 4 pi t. Sin 4 pi t. Sin theta differentiation. What is the sin theta differentiation? Anyone? Sin theta differentiation. Sin theta differentiation. Cos theta. Sin theta differentiation is d sin theta divided by dt. What is the sin theta differentiation? Dt. Cos theta. But if let us say sin 2 theta, what is the differentiation? Anyone? Sin itne theta. Differentiation? 2 will come out. 2 cos 2 theta. 2 cos 2 theta. Because 2 is coming out before the t. So before the t, what are there? 4 pi is there. The 4 pi will come out. So it become, the 4 pi will come out. It become 4 pi into 5. It is Ashrin. Ashrin pi t cos 4 pi t. So this is your a and b term differentiation. This one. So milliamperes as it is. Now the current at 0.5 second. So he want the current at 0.5 second. Comes Nustania. Then substitute wherever the t is there. T here 0.5. So 4 pi into 0.5. It become 2 pi. Here 4 pi into 0.5. It become 2 pi. Another t is here 0.5. So 20 times 0.5 10. So 10 pi cos 2 pi. So substitute all the values. 5 sin 2 pi. Plus 10 pi cos 2 pi. Substitute, you will get 31.42 milliamperes. Here pi, what you have to take? Here, outside the sign, the pi should be 3.142. Inside the sign, what should be you have to take? Degrees. Inside the sign, you have to take the in degrees. So, what you have? Sin 2 into 180 degrees. Pi is 180 degrees. So sin 360. Sin 360 is nothing but sin 0. Sin 0 degrees. How much? 0. Here also. cos 2 pi, 2 into 180, 2 into 180, 360. Cos 360 is nothing but cos 0. Cos 0 is nothing but 1, 0 degrees. So what happens? So 10 pi into 1. So the value is 3.142 multiplied by 10. So 31.42 milliamperes. So like this we have to calculate the total current from the charge. Now this reverse way. We got a current, we need a charge. So determine the total charge entering a terminal between time 1 second to 2 second. From 1 second ila itne second. If the current passing the terminal is I equal to 3t square minus t. So what is the equation? Integration will come here. Same equation. See, here the same equation, but we need q here. But here we need I, so that's why dq by dt. Now we need q means what? We have to integrate I with respect to time from time 1 second to 2 second. See here. So it is q is equal to from time t is equal to t0 to t I dt. So I substitute here. What is I? 3t square minus t. So now integrate. T square. What is the t square integration? Differentiation. Okay. T square differentiation is nothing but 2t. Because t power n it is there. N minus 1. N will come here on the left side and n minus 1 will be there. But integration it will be reverse. What it will be? T square. It become t cube by 3. T cube by 3. So 3 will cancel here. So t cube will be there. T power 3. Now t integration t power 2 by 2. T power 2 by 2 is nothing but this one. T power 2 by 2. So now t power 3 minus t power 2 by 2 from 1 to 2 means for Wahed Thaniya what is the value and Ithnain Thaniya what is the value. So for the Ithnain Thaniya what is the value? T 2 power 3 how much? Ithnain 2 to the 4, 4 to the 8. Now 8 minus here 2 power 2 4 divided by 2 again 2 it is 1. Okay, I'm substituting 2 for 1 and here. So now substitute 1 in the t cube. What is the t cube in 1? It is 1 power 3 or 1 power 100, 1 only. So 8 minus 1. Now second minus t power 2 by 2. So t power 2 by 2 for 2. That is t square. That is 2 into 2 4 divided by 2 it is 2. Minus at 1. So 1 square. So 1 it is 1 by 2. So 2 minus 1 by 2. So just 8 minus 1 7. 7 minus 1.5. It is 5.5. So this is your this one. So in previous class we already studied about the introduction of the electrical circuits and we studied about charge, current, and what else we studied? Yeah, their equations and how they are related, and what is the conventional current we studied, and some problems also we look into. Then today we will study about voltage and power, inshallah. So what is the voltage? Now electrons move when there is a difference in charge between two locations. So as per the definition of the charge and current, electrons are movement. The electron movement is called current, right? So by itself the current will move? No. So we need some thing called energy or something called work to be done to move that electron. Means we need some push. Means some force we have to apply so that the electrons can move from one point to other point in a silk or in a wire, let's say, or in a material. So that moving force is called as a voltage. Means that is called a potential. Means if we have a potential enough to move the electrons, then only the current will flow. That potential is nothing but your voltage. The potential is nothing but your voltage. Okay, this difference is expressed the potential difference or voltage. Means in between 2 points, if we have some potential, some push, then the movement of the electrons will take place. So that is called as a potential difference. Means the difference of potential, higher potential to lower potential. Right, and that is also called as voltage. In electrical terminology, we call it as a voltage. In physics and science terminology, we call it as a potential difference. Both are same. The voltage VAB between 2 points A and B in electrical circuit is energy or work needed to move a unit charge from A to B. So what is that? So let us take, we have a movement of current in point number A and point number B. Then the voltage across that point A and B is called as VAB. Between 2 points, the 2 points A and B in electrical circuit is nothing but a energy or work. Energy means work done is called energy. Energy or work needed to move a unit charge from A to B. From A to B, if a unit charge, 1 coulomb, is moving, then that is called VAB. Means how much energy or work done is needed, that is called VAB, that is voltage or potential difference. And that is given by work done required for a unit charge movement. That's what it's called, rate of charge per work done. Rate of charge per, also called as energy. What is W here? Energy or work done. So rate of charge for a unit charge coulomb movement for the energy. So dW by dQ is nothing but VAB. Rate of charge for the energy is called your voltage, where V is energy in joules and Q is a charge in coulombs. Now 1 volt generally is given by 1 joule per coulomb. But 1 joule, what is 1 joule? In the MKS unit, Newton per Newton meter, means work done. For 1 meter, how much work is needed? That is called work done. 1 Newton meter per coulomb. Another definition we can say, voltage or potential difference is the energy required, that is this energy W, the energy required to move a unit charge through an element measured in volts. So simple definition, many are there, any one you can use. First definition, second, third, any definition you can use, whichever you understand well, you write that one. So I think this one is very simple. Voltage or potential difference is the energy required, the amount of energy required to move a unit charge through an element. Element may be any material. Element measured in volts. Another voltage is also called electric potential difference. Potential difference, right? Voltage is also called electric potential difference. Is measure of how much energy per unit charge. See how much energy W. How much energy W per unit charge. Available. How much energy per unit charge available to push electric charges through a circuit element. Means how much energy per unit charge is available to push the electric charges through a circuit element. It's like a pressure. Means it's like we are maintaining a pressure to move from particles from one point to other points. That drives electrons through the wire. So this is about the voltage. So we can see that circuit diagram here. This is the point A and B. The voltage VAB is nothing but the energy required to push the current or charge from point A to B. So in figure, what is showing? Shows that voltage across element. This voltage across element A and B represented by rectangular blocks. This block may be resistance, may be a voltage source, whatever. This is a block. That's it. It's an element. So anything will be inside. Maybe resistance, inductance, capacitance, or a voltage source, battery, anything. Connected to point A and B. The plus and minus signs are used to define reference. This plus and minus are used for the reference. Means it is a positive voltage or negative voltage. Reference direction or voltage polarity. The voltage VAB can be interpreted in 2 ways. In 2 ways we can say, what are the? First one is point A. The point A is at a potential of VAB. At point A is the voltage or potential of VAB volts higher than point B. Means A is higher voltage because positive sign. Because of the positive sign, we say A is a higher potential than the lower potential B. So VAB can be interpreted as point A is at a potential of VAB volts higher than point B. Okay. Another way, the potential at point A with respect to point B, the potential at point A with respect to point B in between A to B is VAB. Simple way you can say. Or we can say VAB is at higher potential at A with respect to lower potential at B. it follows logically in the general VAB is equal to minus VBA. If you change this VBA, then it becomes minus sign will come because higher potential is at A, lower potential at B. So if you change the name VBA, then what it means? We are referencing B as a first, then A as second. So negative sign will come. If you say VAB, then at positive terminal A should be their higher value. Then it is plus VAB. If we are taking VBA, then it will be minus sign will come. Observe here. What you see the difference here? A and B plus the sign is here 9 volts. Minus and plus is there and minus 9 volts. Are these two are equal? Are these two equal? Yes, because when we consider as a VAB, then it is 9 volts. Now here also if we consider as a VAB and it is minus 9 volts and plus minus is changing. So both are at same potential, both are same value. So point A is 9 volts above point B is minus 9 volts point A, means same idea it is, because minus 9 volts means plus 9 volts is reverse. So both are same. Okay, how it look like? See, now let us take a tank we have a pipe and there is a wall and there is a pressure meter we can check. Now this is called your potential, this is called your voltage. Now if we have water full of this, we will get some pressure of a water output there. If you open it, we will get some X pressure. Now let us take tank is only half is filled, Now open the valve. The pressure what we get the water is same? No. It will be half than the previous one. Because the height, the water volume is your pressure and the height. Both together is called your potential. We call it a potential means the amount of energy what we have based upon the height and the volume. So it's the example I am telling how the voltage can be taken. For example, in your car, the battery, you have battery, when you open the lights, full light will come, right? Not start the car, just battery on the battery. Open the light will open. Now let us take battery is Gadim. What happens when you open the car, not open, just open the light, that light will be dim. Why? The battery potential, the voltage is less, half full. So like this here. So here if it is full, water in this, full voltage. And half means half voltage, means decrease voltage. So it's called potential. So then we come to the equations now. Okay, now let's go to the power, because in power we can see the equation for voltage and power both. Power, what is the power? Power is a time rate of expending or absorbing energy measured in watts. Means it's now we got the voltage, we got the current. Now let us take how much energy is dissipated, how much energy is used, how much energy is delivered, okay, with respect to time. With respect to time. For this time, this much is waste. This time, this much is waste. This is called power. Time rate of energy means time rate of absorbing energy or delivering energy, whatever. Both are same. Both are means delivering means giving. Absorbing is also taking. Absorbing means taking. Wasting energy. So it is measured in watts. So let's have another example. Power is the rate at which energy is transferred. First point. Power rate means time. With respect to time, at how much rate is transferred, means given, it's gone. Used is istemal, means how much it is used. Transformed, for example, what is transformed here? Transform means we give the power to the light, right? What exactly is flowing? Electrons. What exactly the voltage? Potential difference, right? But what we are getting? Light. So the energy is transformed. Electrons energy is transforming to the light. Like you are in Abha, we need what we call room heater, oil heater, let us take. Room heater for the bulb, right? So when you give the electricity, what inside we have? We have heater. Heater means we have a resistance. What resistance is taking? Current, means electrons. But what it is giving to us? Heat. So the electron energy is transformed to heat energy. This is called transform. So energy transferred,
used or transformed. So power is the rate at which the energy either transformed or used or transferred. So in electrical system, it tells us how fast energy being delivered or consumed. So for light, for the heater, example, what happened there? It is consumed, means istemal. Now for the battery, from the car, we are giving the power battery. The battery give the power to the light, right? It is delivering. And light hada istemal, means you consume. It means eating and giving, we can say. Okay. What is the definition again? Power is the rate at which the energy is transformed. So we can write the relationship rate at which the energy is transformed. What is W here? Energy, dW by dt. Rate means with respect to time, dW by dt. The time rate of energy means how much it is dissipating or absorbing or delivering. You can tell dW by dt. Where W is, P is the power. Symbols remember the P. Volts V. Current I. Energy W. Time small t. Already you know, right? And charge Q. Q is the charge. So where P is the power in watts, the units are watts, capital W. Don't confuse with W and this W. Be careful. The Sagi W is for energy. Istemal for equation. Okay. Capital W is the watts. Istemal for units. Not istemal for any equation. Not equation it is units only. Like degree Celsius, degree Fahrenheit, ohms, right? Volts, capital V. Amperes, capital A, like this units it is. So small w is energy, capital W is watts. So now small w is energy in joules, capital J you can use, and T is the time in seconds. So now the power, the P, the power is the time varying quantity because it is dW by dt. It means time varying. Due to the time only the value will change. Time varying quantity. And is called instantaneous power. Means time to time when it is changing, it is called instantaneous. Time to time we are changing our life. It's called instantaneous. Humans are instantaneous. In one age it will be small. After some age it will be big. It will become like that. After that it will die. So instantaneous means changing with time. It's called instantaneous. So the instantaneous power. So P is equal to, we can write voltage multiplied by current. Instantaneous power always given by voltage multiplied by current. So what is voltage in terms of basic equation? It is charge rate of energy. dW by dQ is your voltage, potential. What is the potential? How much for unit charge movement, how much energy required is voltage. For unit charge moving, for moving the unit charge, how much energy required? dW by dQ is called voltage. What is current? Current already you know. Time rate of change of charge, right? In 1 second, how much charge is moving? Time rate of change of charge. That is current. I. Already we studied V and I. So V is dW by dQ. I is dQ by dt. Now cancel dQ and dQ. These two will cancel. Then remaining dW by dt. Right? So we get the final equation like this. You got it. We proved the equation. So this is your major equation. Power, which have the V and I, and V is this equation, I is this equation. You remember this complete equation? Class, you got I, V and power. Talat item mode. Right? Okay. See here. There is element and there is a positive sign and negative sign, and there is voltage positive and negative sign, and current is entering. Current is entering to the element. And here positive sign, same negative sign, current is leaving. So when current enters the positive sign, we remember here, when current enters the positive sign, then it is called power utilized, power consumed, eat. Like your light, power it will take, means current go inside. Current go inside. So it is called positive power, means it is eating, it is delivering, means it is absorbing, is called. Now current is giving. Where this happened? Current is giving. Going out. From where it will go? From the battery, from the power source, where the generator is there. Power will go, means current will go out. But in elements like light, heater, any element, the current it will take, then power absorbed. So both are different. So P is equal to, if current is entering the positive terminal, it is called plus VI, power. Now when current is leaving the positive terminal, then it is called minus VI. That is opposite. Here it is absorbing, here it is delivering, giving. So same thing I am telling here. See, reference of polarities of for power using passive sign conversion. First one is absorbing, because current is entering. In positive sign, current enters, it is absorbing. When current is leaving the positive, it is leaving. If power P has positive sign, the power is delivered or absorbed. If the power is absorbed by the element, example, resistor, motor, heater, light, it will absorb the power. If power P has negative sign, like here, negative sign, then the power is returned, or then it is done by source.
Okay, we will take another one. So, if power P has negative sign, then the power is being supplied. Power is returned to the source. Example, capacitor, inductors are temporarily energy source, these we call. Okay, now coming to the equation, power and energy. The laws. Law of conservation of energy must be obeyed in electrical circuits. What is law of conservation of energy? Energy can't be created, can't be destroyed. Means we can't create or we can't destroy it. Just we can transform it. We can transform it. We can transform it, means transfer to in another form or transfer to from one place to other place. That's it. So as per that, what it is telling. So the total power supplied to the circuit must balance the total power absorbed. Means you have a battery, you have a lamp. Okay, one battery, one lamp. So the energy given by the battery is absorbed by the lamp. That's it. Whatever is giving, it should be absorbed. It's called balance. Dunya is a balanced one, right? Allah created dunya for making balance life. So it can be transformed, it can be transferred, but it should be a balanced one. It cannot be destroyed, it cannot be created. That's called law of conservation of energy. So whatever the power absorbed is equal to power supplied. So total power is 0. So the energy absorbed or supplied by an element from time t0 to time t, from time x to time y, or we can say time t0 to time t, is nothing but this is your energy. W is equal to P, which is integral from t0 to t dt. P integral t0 to t dt. Then what is P? We know. What is P? Voltage multiplied by current. So in the voltage, it may have sine wave, or it may have some equation, exponential equation, sinusoidal equation. Then we can integrate it. So we'll see in the example problems. So energy, what is energy? Energy is a capacity to do work. So what is energy exactly? It is a capacity or a work. Capacity to do work measured in joules. Now 1 watt hour is nothing but 3600 joules. This is a transformation of the MKS unit to the SI units. 1 watt hour is equal to 3600 joules. You have to remember this one. Okay, now coming to how the sign of power is influenced by the current direction and voltage polarity. Means here how we know that power is absorbed, how we know the power is delivered, given, how we know. So that is given by the sign. Means positive, negative. Sign means positive, negative. For the positive power sign, the voltage polarity and current direction must match those in the figure 1.9. Means the current should enter the positive sign of the voltage. Then only it is called absorbed. Okay. If the current leaves the positive sign of the voltage, it is called delivered, given. See here. What it is showing here? Positive sign of the voltage, positive sign and negative sign. In the positive sign, current is entering. So what it will say? Power absorbed, eaten, taken. Okay. Here, negative sign, current is leaving. What it means? Are these two same? Positive sign, the current is entering. Negative sign, current is leaving. So what if current is leaving here? what is happening here? It is entering, right? Circuit. In a circuit, there is a closed circuit. So what happens? Here, the closed circuit is there. The current enters from positive and leaves from the negative. But here I am telling that it leaves from the negative means what means? In positive it is entering only. So these both are same. Okay, these both are same. Power absorbed only. See, two cases of elements with absorbing power. Absorbing means eating power, means utilizing power. That is 4 into 3. What is power? Voltage into current. Voltage into current. 4 into 3, 12 volt, 12 watts. So what is P? 4 into 3, 12 watts. Here also, in this also, what is P? 4 into 3. Because current is here minus, it's leaving, but what it means? It is entering positive only. So both are same. 12 watts positive absorbing power. Now coming to Tani. For negative power sign, the voltage, polarity and current direction must be matched as shown in the figure. Now check here. In this positive terminal of the element, that is voltage, positive terminal, current is leaving. Means in negative terminal, current is entering. Here, in negative terminal, current is entering and positive terminal, current is leaving. So what it means? It is opposite to the above one. Opposite to the above one. So here voltage and current opposite direction. Positive and current is leaving. So minus 4 multiplied by 3. Here also minus 4 multiplied by 3. So negative power, it is called power delivering, giving out. You take it, giving out. So power P is nothing but minus 4 multiplied by 3 minus 12 watts. Same here also. Minus 4 multiplied by 3 minus 12 watts means power is delivering. Just remember simple concept. Positive of the voltage, if current enters, voltage power is positive 4 into 3. If current leaves the positive terminal, leaves outside from the positive terminal, minus 4 volts or minus V and I. Power given. Passive sign convention, how to know? Okay. Passive sign convention is satisfied when the current enters through the positive terminal. Same thing I am repeating. Passive sign convention is satisfied when the current enters through the positive terminal of an element, P is equal to plus Vi. Okay. If current enters through the negative terminal, if it is enters through the negative terminal like this, enters through the negative terminal, then power P is equal to minus Vi. Okay, now we have an example. An energy source forces constant current 2 amperes for 10 seconds. Here what it is given, the energy source means the supply, power supply is energy source is forces a constant current, means itne ampere current is moving for ashrataniya 10 seconds to flow through a light bulb, to the light, let us take. Okay, this is one thing. 2 amperes we got I, time we got 10 seconds. Now what is the sawal? If 2.3 kilojoules is given, let's take इतने फासला तलाता kilojoules means कम आधा इतने अल्फ तलाता मिया joules is given of in the form of light means conversion, transform. The current is transformed to how much? 2.3 kilojoules light energy. Light energy is they are telling. So it is transformed to 2.3 kilojoule as a light energy and heat also. Both together he is mentioning. Sometimes it room heaters, it have the light and it have the heat also. You can see red hot will be there. Red is a light and we get the warm heat. So both is there. So heat energy. So calculate the voltage drop across the bulb means how much potential is forming there. Because of that potential we can get 2 amperes current and we can get 2.3 kilojoules of energy because of the potential only. So what is that potential voltage? What is the voltage we need? So how can we know? See here. We know the total charge. What is the total charge? Because he is telling that clearly for how many seconds? 10 seconds. So how much charge? D delta Q. What is the delta Q? Total charge is nothing but I current times T. Time rate of charge is nothing but current. If you make it reverse, multiply the current with the time, it is charge. Time rate of current is your charge. Q is equal, I equal to time rate of charge, dq by dt. If you want Q, what we have to do? Take the time to this side, current side. So current multiplied by time, it is your charge. So 2 is the ampere current and 10 is the seconds, Tanya. So 20 coulombs is the charge. Now once we know the charge, we can know the voltage by the equation. What is the voltage equation? Energy, charge rate of energy means how much charge required for that energy, how much charge is dissipated or required for the energy or work done. V is nothing but dW by dQ. Delta W or delta Q, same, dW by dQ it is. That is approximate equation. This is equal to, when it is there, total dW by delta W by delta Q will come. The previous equation what we study, it is dW by dQ. Why? There is no equality there. There is a proportionality there, right? When equality is come, exact value we need. That is delta W means how much energy, how much charge exact we need. So delta W by delta Q. So what is delta W? Already given 2.3 kilojoule. That is energy. 2.3 into 10 power 3. What is the charge total? 20. So just divide 115 is the potential difference required to get 2 ampere current. And for 10 seconds, it will give the energy 2.3 kilojoules. Now another question, how much energy does have 100 watts electric bulb consumes in 2 hours? Good question. Now we have in houses, we have many lamps, anything. Just you have to think like a designer, engineering designer, right? We have 100 watts lamp, right? Now in 2 hours, how much energy is produced or transformed, consumed, we can say. So lamp is there, what it will do lamp? It will consume, eat. Because it is giving in the light form. So it will take the power and give in the light form. It will not deliver. So energy, 100 watt is there. Now what is the W? Energy is equal to P times T. What is power? What is power actually? Power is equal to time rate of energy, dW by dt, right? Now what is energy? Just reverse. Multiply power with the time. Multiply power with the time is energy. Just opposite, vice versa. What is power? Time rate of energy, dW by dt. Now energy, multiply power with time. So we are multiplying power with time. What is the power? 100 watts. Power is 100 watts. What is the time t? Kamsa? Itne insa? 2. But time should be in what? Time rate of energy. Time rate of is in seconds. Tanya, right? So itne insa maujud. Maafi tanya. So convert is 2 hours to seconds. So 2 hours multiplied by 60 minutes in per hour and 60 seconds per minute. Now kullu 720,000 joules or 720 kilojoules. Also, no, it is in joules. No, I want electrical. I want SI units. Wattage I want, right? Then or watt hour. Energy, 2 units are there. One is joules and watt hour. Wattage hour. In 1 hour, how much energy? Watts. How much power? In 1 hour, how much power? It's called watt hour. So W is equal to is nothing but PT. No need of converting the 60 minutes and 60 seconds because it is hour. But joules, it is in seconds. Joules always in seconds. Okay. So that's why 100 watt multiplied by 2 hours. It is 200 watt hour. Whatever electric meter inside our home, outside our home, the meter is there, na, that. So always measure in watt hours, kilowatt hour, not watt hour, kilowatt hour. Not in joules. They will not calculate in joules. Okay, watt hour. Joules is very small quantity. It will give very big value. Because see here, come hada saba miya ashrin kilo. Hada only methane. And if you convert it into kilowatts as per our home, it is 0.2 only. See for fasla itnen only. Because kullu yom hada itnen sa. Kullu yom kam sa? Arba ashrin sa. Kullu yom, right? Like kullu shahar, because hisab hada shahar, right? So for 1 month, 24 hours for one day, and for 1 month it is 24 into 30. So many hours. So multiply in joules, you will get it in joules means a big value will come. So all that in electrical, what we have in watt hour or kilowatt hour we can say. So another example. Okay, some examples are there here. See here, water flow drop height. So what is the potential? This high energy level to the low energy level. If you see here another example here, this is a battery and this is a motor. It absorbs the energy to rotate. Now plus, where is the plus? On the top. So where is the higher potential? On the plus side. Where is the lower potential? On the minus side, means downside. Plus is higher potential, minus is the lower potential. That's I want to tell. Now here also same. This is a voltage. What is the potential? Voltage means potential. And this is the resistance. We will come to next class about the resistance. Means it controls the current movement of the electrons. And this is the current. Now based upon the pressure, the current speed will change based upon the what we call the height of the volume inside the tank. If it is more height, means more volume inside the tank, then the current will pass more, means very fast. Amount same, maybe not, but very fast. And the resistance will control that current, how much this has to pass, X value, Y value, it will change the resistance. We'll see that one. Okay, last example, then we'll stop here. Okay, find the power delivered to an element at t is equal to 3 seconds, 3 milliseconds. If the current entering its positive terminal is, so be important, current entering its positive terminal means what it means? Power used, power eaten, power taken, like your lamp, right? So at t is equal to 3 milliseconds, the current is 5 cos 60 pi. Pi here, if it is inside the cosine term, if it is inside the cos, sine, if a trigonometric term is there, the pi value is how much? What is the pi value? Come, Hada. Pi is equal to dash. Anyone? Both are correct only, but not the correct. Miyatamanin also correct. Pi is 3.142 is also correct. But my question is exact when it is inside the cosine term. Inside, if you use the cos sine term, you have to use in in degrees. 180 degrees, 360 degrees, 16 degrees. You know the cos 60, how much? Cos sifar, come, wahid. Cosine sifar degrees, come, 1. Sine sifar degrees, come, sifar. Sine 90, 1. Cos 90, 0. So like this, inside the cosine terms, its value is different. That is Miyatamanin istemal. Outside the pi is coming out, he is writing 5 pi. Then there you have to use not 180, we have to use in radians per second. That is 3.142. So just remember, everywhere it will come in the electrical circuits. Okay. So now what is the voltage? When V is equal to 3I, so what is the power? Power is equal to what? Power P is equal to voltage multiplied by current, VI. So we got I, we got V. So we can find the power. So power is equal to VI. So what is V? 3I. What is I? Again here is there. So 3I square will come. Check here. The voltage is 3I. That is 15 cos 60 pi t. Okay. This is your voltage because it is 3 times. 3 times of the I. 15 cos 60 pi t. Now what is P? V times I. Already V is having 15 cos 60 pi t multiplied by I. 5 cos 60 pi t. So 5 multiplied by 15, 75. Cos 60 pi t, cos 60 pi t, zarb. Cos square 60 pi t. Cos square 60 pi t. Now, this is the final equation. Now, we want the power at Talata milli Tania. What is the power? So, at t is equal to 3 milliseconds, P is equal to how much? So, substitute what is time? T. Here is a T. Substitute T value. That is 75, same. Cos square is same. 60 pi, here pi use 180 degrees. 180, 60 multiplied by 180. What is T here? 3 milliseconds. 3 into 10 power minus 3. Then you will get cos square, the 60 multiplied by 3. That is 0.18 because it is a 10 power minus 3. So cos square 0.18 pi. 0.18 multiplied by 180. So you will get some value. That is 53.48. How you will get the value? First find the cos 0.18 into pi. Okay. Then square it. What is a cos square? It is cos power square. Once you get the cos value, then make it whole square. That is the one. Next. Second one, when V is equal to 3 di by dt. First one is okay with 3 Vi, but second one is time rate of current he is giving. 3 V di by dt means you have to differentiate first, then substitute in the power. So we find voltage and power as V is equal to 3 di by dt. So what is I here? Phi cos pi t. Now it is very important. Now be careful. 3 di by dt. Now differentiate this phi cos 60 pi t. Cos we have to differentiate. When you differentiate cos 60 pi t, because phi is a constant, no differentiation for it. Only cos we can differentiate with time t. So cos A, let's say cos theta. What is the value of cos theta? A differentiation? Sin theta. Now let us take. We have cos ethane theta. Cos ethane theta. Juva. Inside 2 theta is there. What is the differentiation? Cos ethane theta. So the ethane will come out. And the cos ethane theta will become sin ethane theta. So inside the cos or sin term, it will come out. Like what it is as? Juva, what did we have before t? 60 pi is the constant. So this constant will come out. See here. This constant is come out. But cos differentiation minus sin. Sin differentiation cos. Sin theta differentiation is plus cos theta. But cos theta differentiation is minus sin theta. Okay. So that's why the 60 pi is coming out from the cos, and that is minus 60 pi. And phi sin 60 pi t as it is. Now the value, if you multiply, it is minus 900 pi sin 60 pi t volts. Now once you know this equation, that is voltage minus 900 pi sin 60 pi t, then you can find the power Vi. So what is V? Already we know. That is minus 900 pi sin 60 pi t. What is I? It is phi cos 60 pi t. Multiply phi into 900. It becomes 4500 pi sin 60 pi t will come, cos 60 pi t will come. So both sin and cos both are there. Now we need at time t is equal to 3 milliseconds. Time t is equal to 3 milliseconds we need. So substitute 3 milliseconds inside this one, sin and cos, use pi as 180 degrees. Now here, outside there is a pi again. Outside the pi is there, inside again pi is there. Inside we have to use 180 degrees. Now here outside pi we have to use 3.142. Now multiply, you will get minus 6.396 kilowatts. So like this we have to calculate step by step. You need calculation skills for this. Now next class we will start the circuit elements. Okay, let's start our point. So power and energy we have to study today. In previous classes what we studied? We studied from basics, what is a circuit, why we study electrical circuits. Then we studied charge, we studied current, we studied voltage, and we studied power and energy also. So I think this is power and energy. Yeah, this also we studied. How the pressure is built up and what is the voltage, what is the current we studied. Then we had an equation for what we call power equation and voltage energy equation also we had it. Some problems also we studied like these problems. Now we have to study today the circuit elements. What exactly the circuit element means and what included in these. So there are two types of elements found in electrical circuit. That is called passive elements and active elements. As per name itself it is telling. Active elements means which are very very active and which is ready to give the power. It's called active. Or which can store energy and deliver the energy. This is also called active. Means passive and active. Passive means only absorbing type. Means resistor generally, for example lamp. What is a lamp? Inside there is a resistance. So it will absorb energy. It can't give energy. It can't give electrical energy, I am telling you. It can't give the electrical energy. It can give the transformed energy like light, heat. It will give. Means it absorbs and give. But it cannot generate. So that is called passive elements. Active means which can give the power or like voltage, current, which can give. Or which can have a potential in it to supply the power. An active element is capable of generating energy. So what I told you, the generating energy which it can generate by its own. Maybe it has some means like generator. It must be come from a rotating part. It must come in nuclear fission. It may be come a battery which have a potential. But it must give the power, electrical power. It's called generating energy. Example, generators, batteries, operational amplifiers. The operational amplifiers are not direct generators, but it can amplify the signal. If we have 5 volt signal, it can give the 25 volt signal. Means amplify, means it can give its own capability, more than its own capability. Next, a passive. A passive element cannot generate energy. Example, resistor, capacitor and inductors. So resistor, capacitor, inductors for DC circuit generally it is a passive. For AC, when it is stores energy, then it becomes active. Okay, but we are studying now only DC circuit. In chapter 7, 8, you will study AC. There I will tell. So now resistors, capacitors, inductors are now basically a passive circuit which takes the energy and dissipates, converts, transforms. The most important active elements are, what are the active elements? What are the active elements? I know that these are the generating elements, which are the generators, batteries and operation amplifiers. In this, what are the most elements are there? Voltage sources. In generator, what it is? Voltage it will give. In generators, what? Current it will give. So, generally we mention it as a voltage sources and current sources. And that generally deliver power. Means together only it is a power. Voltage is there. Due to that voltage, current is there. Due to Jama, these two, only the power, VI. Without that, there is no generation or there is no power. So, generally deliver power to circuit connected to them. And that circuit must have a passive elements like resistor, inductor, capacitor, which takes the energy. There are two kinds of sources. Now, we have to know what is the current source, what is the voltage source, we know it. What is the voltage, what is current, we know it. But in this, we have two types of current sources. One is called independent sources, means let's have 5 volts battery. It's independent, 5 volts only it will be. Okay, it will not depend on any other things, other thing in the complete circuit. It has its potential to give 5 volts, some current based upon the circuit elements. But it doesn't depend on any other part of the circuit. It is called independent. What circuit means what? It may have voltage source, it may have a resistor, inductor, capacitor, many things will have. The source which doesn't depend on other elements. That elements may be a voltage source, may be a current source, may be a resistor, inductor, capacitor. It is not depending on other elements, then it is called independent. Independent, not depending on other things. So this is called independent sources. In that, voltage and current source are there. There are another type, it's called dependent sources. So quite opposite to the independent source. Quite opposite to the independent source is dependent source. Means some of the elements are causing the source to change its value. Causing source to change its value. Now, so next circuit in this, an ideal independent. So what is ideal? Ideal means it doesn't have any power loss. It doesn't have any leakages. Okay. So an ideal independent source is an active element that provides a specified voltage or current. That is completely independent of the other circuit element. Same. This is like a independent source only. But ideal I am adding because we have, it's called, it doesn't have any problem in it, any leakage or any losses in it. So that is called ideal. Source is an active element that provides a specified voltage or current that is completely independent of other circuit elements. So on other circuit elements, it won't depend. Now, what is like example? Here voltage source, we can denote in two ways. That is in the circle, the diarrhea, plus minus also we can write, that is V. And one big line, one small line with plus and minus. Big line always denotes plus, small line always denotes minus. Okay, so this also one way. In this is particularly, we could say this is a battery, DC source, completely DC source. Here where this is a diarrhea and plus minus is there, then it is a battery. Okay, if we have a sign symbol in it, in the diarrhea there is a sign symbol, sinusoid symbol is there, then that is AC, alternating current we call. That's why I denote voltage V, which is called instantaneous voltage. Means time to time it will change, instantaneous. What is sign? Time to time it will change. It will go to 0, go to the maximum, go to again 0, go to negative maximum, again 0. Time to time it is changing. So instantaneous voltage. So it has two forms. Plus minus, if you write, it is capital V it will become. That is DC volt. If we have sine wave in it, then it is a AC source. We call AC voltage source. See, symbols for independent voltage source used for constant time varying. This is time varying. That's called instantaneous or time varying. Time to time it is varying. Now this is for constant voltage DC source. It's called constant, used for constant voltage source. Now coming to current. Same. The current, we have only one symbol. That is daira lazim. Inside there should be an arrow. AC, DC, all are same. If you put AC sinusoid inside the daira and the direction, also good, no problem. But direction is important because there is no plus minus symbol for the current. There is no plus minus symbol. There's only direction from left to right, right to left, upward or downward. This is upward, from down to upward. So direction of the current will be there, and daira lazim. For AC, we have daira, inside plus minus DC. If we have only plus minus with the big and small line, it is purely DC. So this is how we denote the independent ideal voltage source. Independent voltage source also we can say. So this is the example. Now coming to the other part, dependent. An ideal dependent or controlled, we also call that. Dependent also named as control, means it is controlled by something else. Means it is not the what we call by its own, it is doing its job. It is controlled by something else. Like me, I am teacher here. I am controlled by Java Molecular College, right? From president, the ranks are there. So like this, I am a dependent one. President is an independent one. So like this, we have a controlled one. An ideal dependent or controlled source is an active element. It's also active element. I am not talking about passive. It is an active. Active, we have two, dependent and independent. So active element in which source quantity, the value of the source quantity, maybe voltage, maybe current. Source quantity is controlled by other voltage or current. Other voltage or current. Okay, somewhere in the circuit, some resistance will be there, some capacitance will be there, or some other voltage also there, some other dependent voltage source, non-dependent source, that is controlled. Okay, dependent sources are usually designed by diamond shaped symbol. Okay, now good point. How to denote this one? In previous case, ideal independent sources, how we denote? With diagram, circle, right? Circle line plus minus, the heavy line and Sagir line, right? But here you have to differentiate. Now we have to use the diamond shape. For example, see, this is the diamond shape of the voltage. This is diamond shape of the current source. If it is shape is diamond, inside maybe plus minus, inside maybe a sinusoid, it is a dependent voltage source. Dependent AC voltage source if sign is there. Plus minus is there, dependent DC voltage source. Now here current, it is direction only. So AC, DC we cannot interchange. So this is AC or DC current source. Dependent. We have to be careful. Dependent. If it is daira is there, that is independent. Okay. Now another. Okay, this is okay. Now what is exactly controlling? What are the different ways of its controlling? Okay, independent. Okay, voltage means voltage. It is independent. Its own. He is capable of doing anything. Its own. Current also its own. It can do anything. But independent, we have a doubt. Okay, who are the controlling factors? Okay, so in this we have 4 types. Arba types. First one, there are 4 possible types of dependent sources. First one, a voltage controlled voltage source. See, it's basically a voltage source, but who is controlling this? Other voltage. Other voltage. Now, it is a voltage source. I am a voltage source, but I am controlled by, same like me, other voltage source. Okay, so voltage controlled voltage source. Next, a current controlled voltage source. I am only a voltage source, but I am controlled by current control. Some current control voltage source. Some current source is there somewhere that is controlling me. That is I am voltage. So current controlled voltage source. Just opposite by giving. So basically I should be current source. And I should be controlled by a voltage source, or I should be controlled by a current source. So same, these two acts. What is here? Voltage source. Voltage source means basic, originally it is a voltage source. Controlled by either voltage source or current source. So make it opposite. Can you define the name? Just opposite it. So basically what it is, voltage source, right? These two. Now the remaining two, basically what it will be, current source. It is a current source. Now one option is there, it can be controlled by a voltage source. Voltage source, current source. Voltage controlled by current source. Another one, current controlled by current source. So like this we have voltage controlled by current source. See, Vs common here, voltage source. Here these two Cs will be common. Right? It is controlled by either voltage source or a current source. See, current control current source. CCS, then VCCS, CCVS, VCVS. So like this we have four types of control. This is a very important in circuit analysis and for multiple choice questions. What is the full form of this one? How many types are there? Maybe ask. Okay, dependent sources are useful in modeling elements such as transistors, operational amplifiers, and integrated circuits. For our what we call electrical, pure electrical, like our household, industrial, big industrial, generally we are not dealing this one. But computer engineer, what is a computer engineer? Inside computer, which parts are there? Small circuit, IC, integrated circuit is there. Amplifiers are there, capacitors, inductors are there, right? There we need this type. There you need, where element transistors are there, amplification will be done, controlling will be there. Transistor means controlling only. So any doubts in this? So we have four types of dependent sources and it is diamond shaped, important diamond shape. Now coming to some problem. Calculate the power supplied or absorbed by each element. We have big circuit here. This is a circuit. Now he is telling that P1 we need, P2 we have to calculate, P3 we have to calculate, P4 we have to calculate. Okay, and it's asking absorb, supplied or absorb. What do you mean supplied or absorb? Supplied means it's a generation, means it's giving the power. Absorbed means eating the power, right? So generally it doesn't show here this element is resistor, capacitor, or what it is. It doesn't know. So we don't know it's absorbing or it is delivering. Okay, here it is clearly mentioned voltage source. Here clearly mentioned current source. We can say that okay, this is delivering power, means giving power. But these two elements, what inside we don't know. Then after calculation only we can understand that it is a absorbing or it is a delivered. Just see. So all items are given here. I is equal to 5 is going here. Then I is equal to 6 is going here. And this is a point 2 I is coming to this point. See. We apply sign convention for power. Sign convention we'll put. Because current is moving to the element. So plus minus we put. And current is moving downwards. We put plus minus here. For P1, the 5 ampere current is out of the positive terminal. For P1, this 5 amperes current is as per given, is out, means going out. So what happens it is, when a current is moving out from the positive terminal, it is delivering power or absorbing power. I told you in the last class, when current enters a positive terminal, then it is a positive power, that is absorbing power. When current leaves from the positive terminal outside, go outside, then it is a negative power, means it is giving power, outside going. So that's why 20 into 5 amperes, minus 5, because it is going out from the P, or positive terminal, out from the positive terminal. So 20 is your voltage, current is 5. So power equation V into I, voltage multiplied by I. So 20 is okay, 5 we are taking minus 5, because it is coming out from plus. If it is going inside plus, then it is plus 5. So it is 20 minus multiplied by minus 5, minus 100. So which power we call minus 100 means supplying power, delivering power. Okay, for P2 and P3, current flows into positive terminal of the elements. What is P2? This is P2 and this is P3. So this is P2 and P3. Current is entering. See, current I is entering. How much? 5 amperes entering to the positive terminal. In P3, current 6 ampere is entering to the positive terminal. So these are absorbing power. So our equation will be P2 equal to how much? V. How much? 12 multiplied by I. How much? 5 plus 5, because it is entering. So 12 into 5. How much? 60. Right? Now P3 will be 8 voltage multiplied by current 6. It is positive or negative? Positive, because current entering. So 6 into 8, 48, right? So this is your, see, P2 is equal to 12 into 5, 60, plus what? Absorb, means it's taking the power, mumkin resistance. Now P4, P3, 8 into 6, plus 48, absorb, it also take the power. Now this is P2 and P3 finish. Now what about P4? P4 is like a giving power and controlled one. The problem is, it is controlled with I. Where is I? 5 amperes, right? Controlled power. Now, for P4, we should note that the voltage is 8 volts. The voltage is, what is it? P4, we should note that the voltage 8 volts. This 8 volts is parallel to this one. Same voltage will come here. Okay, positive positive on the top, positive on the top. So current is leaving from this positive, means same will be here. So current is leaving means it is giving the power, minus we have to take. The same voltage for P3. Since both passive element and dependent source are connected in the same fashion, terminals, remember that voltage is always measured across the element in the circuit, across the element. So since the current flows out the positive terminal, we have to take minus 0.2 I. So we have to take minus 0.2 I. Voltage, okay, 8 volts, because 8 volts already is there parallel. These two are in parallel. But here these two are in series. So we can take the same 8 volts. So here only two are there. No other elements are there here. These are in parallel. That also we'll study in the next in detail. No problem. But you just remember these two are in parallel. The same voltage what here in P3, the same voltage will come to the other branch, other element in parallel. So 8 volts is the voltage for this. And what is the current? 0.2 I. But how the current is going? Outside the plus terminal. So it is negative. So 0.8 multiplied by minus 0.2 I. So what is I? Because it is a control source. Where it is controlling? Here. What is I here? 5. So substitute 5 here. 0.2 times 5. So it is 1. It is minus 8 watts. So it is supplied power. So like this we are supplying the power. So we should observe that the 20 volts independent voltage source and dependent current source. This is 20 volts independent voltage source and this is the dependent current source are supplying power to the rest of the network. To the rest of the network means these two. In these two, it is supplied by from this and from this. Okay. Okay. While the two passive elements are absorbing power, these two are taking the power. Now we can have a power equation. Energy neither created nor destroyed. Sum of the all power should be 0. Means I give something, you take something. Right? The something should be matched. Then the total should be 0. That's the law of conservation of energy in the universe. So now all the power, what we have, P1, P2, P3 and P4 should be 0, equal to 0, all summation. What is P1? Minus 100. What is P2? Plus 60. What is P3? Plus 48. What is P4? Minus 8. Jama the kullu? 0. Mia minus together here, minus 108. Plus 60 plus 48, 108. So it is balanced. Like this, law of conservation of energy should match. Otherwise, you made something mistake. It should be, the power should be 0. You can cross check in your exam directly. Okay, my calculation is correct or not, you can tell. Later you can tell, I am correct. Now you give me less marks. No, you can fight for it. Okay, you can cross check in the exam itself. See, and P1 plus P2 plus P3 plus P4 is equal to minus 100 plus 60 plus 48 plus minus 0. Law of conservation of energy. Okay, in agreement to the sum of powers rule, the total power supplied equal to the power absorbed. Supplied means minus 100 and minus 8. Minus 100 and minus 8. Absorbed is 60 and 48. Both are same. Okay. Now coming to the summary in the chapter 1. Then what we studied, we will have some points, that's it. Then we have the some problems also. So much. Okay, another 15 minutes I have. An electric circuit, what it is? An electric circuit consists of electrical elements connected together. Together means either maybe in series or in parallel. That we will also study in the next chapter. What is series, what is parallel? Together means it's a connection, that's it. And the international system units, SI is called international system units. Okay, international is the international measurement language which enables engineers to communicate their results. SI units we call international system units, and that we follow for means measuring the quantities like voltage, current, resistance. We follow that one. like SI units, kilometers, meters. These are SI units. Okay. Now, current is the time rate. What is the current? Is I d equal to dq by dt. Time means time rate means change in time. Time rate of charge. Time rate of change of charge. Time rate of change of charge is nothing but your current. So this is your already we studied. So then voltage. What is voltage? Is the energy required to move 1 coulomb of charge. That is charge rate of change of energy. Same thing like time rate means T hai, right? Time rate of change of charge this one. Here charge rate of change of energy is called your voltage. Or another definition, this one. A voltage is energy required to move 1 coulomb of charge through an element. So dW by dQ, where W is your energy, Q is your charge. Now multiply V and I, dQ will cancel, and dW by dt, time rate of change of energy. Time rate of change of energy is your power. So the power is the energy supplied or absorbed per unit time. It is the product of voltage and current. P is equal to dW by dt, because multiply V into I. See, V into I. Multiply V and I here. So this dQ and this dQ will cancel. Only remain dW and dt. So dW by dt is nothing but time rate of change of energy. Time rate of change of energy. According to passive sign, okay. Now passive sign convention, power assumes a positive sign. Power assumes a positive sign. What it means? It delivers. Means it absorbs, it takes. For positive sign. Okay, sign when the current enters the positive polarity of the voltage. So power positive sign means it is eating. And when it is happening, when the current enters the positive polarity of the voltage side. Voltage already defined, plus minus, higher potential, lower potential. Plus means higher potential, minus means lower potential. Current enters at higher potential means plus, current enters at plus terminal, that is a higher potential means it is eating, means it is taking the power, positive power. When current leaving the positive terminal of voltage means it is giving the power, means delivering the power. Okay, now an ideal voltage or current sources produce a specific potential difference across its terminal, regardless of which the what is connected to it. So what is connected to it is not important. So ideal voltage or current source produce specific potential difference and current. It will give the current, means it will not depend on other elements. That is called ideal voltage or current source. Independent current source also we can say. Voltage and current sources can be dependent or independent. A dependent sources in one whose depends on some other circuit variable. Okay, so these are the important items. Now we have some problems. I think 1, 2, 3. I have equations. I put it 4, 5 also we can see. Yeah, to move a charge Q from point B to point A requires 100 joules. Means point B to point A requires 100 joules. Find the voltage drop VAB. The voltage at a positive with respect to B. VAB means positive with respect to B. Well, what we have to use? VAB is equal to dW by dQ. We have to use the formula. Formula also I mentioned here, and answer also there. So what is dW? What is the dW means? Energy. Right? How much energy we have? Joules. Energy measured in joules. How much? 100 joules. And what is the dQ? Charge. How much charge in A point? How much charge he want to move? 5. Okay, 5 coulombs. So 100 divided by 5 coulombs. How much? 20. 20 volts. That is your voltage. 20 volts. Now another one he is telling minus 10 coulombs. So minus will come here. 100 divided by minus 10. How much? Minus 10 only. Right? So like this you have to calculate by using the formula. Now another question, find the power delivered to the element, that is I is equal to 5. Same equation we have in the previous problem, the same I equal to 5 cos 60 pi t. Now here he is changing some data. So current we have 5 cos 60 pi t. Now at 5 millisecond means 0.005 thania seconds. The voltage is, let's take V is equal to 6I. Now we need what? Power. What is power equation? P is equal to VI. First find what is P is equal to VI, then substitute T 5 milliseconds, you will get the answer. So what is V? V is 6 times I. What is I? I is 5 cos 60 pi t. So 6 times I multiplied by 5 cos 60 pi t. So 6 into 5. How much? 30. 30 I square. Okay, 30. 30 cos square 60 pi t. 30 cos square 60 pi t. So you will get power as 30 cos square 60 pi t. Now substitute t is equal to 5 milliseconds. So 60 pi t. T is now how much? 5 means 0.005. What is pi in then here? What is the pi value? I told you in the last class. Inside cosine, sine terms, what should be the pi? It should be 3.142 or 180. Which one I have to take? There are two options. 3.142 pi value or pi value is 180. What is this? What is the time of the class? 9. Now what is the time? You are coming to listen the class, or you just take the attendance and go? Video is bad enough. If you see here, then you see the video, you get more clarity in fast manner. Come in time. Don't become late. Don't depend on videos. It is for your reference, in future reference, so that you can recall your knowledge. Okay. So what is here? Okay, pi I told you we have two options, pi 180 degrees or 3.142. In this equation, which inside the cos, which one I have to use? Is it 180 or 3.142? Which one? 3.142. Anyone? If you are using the pi inside the cos trigonometry means cos sine term. Inside the trigonometric function for calculating, we have to use in degrees. In degree, 180 degrees we have to use. If the pi is outside in the calculation before the cos term, pi like this is there. There we have to use not in degrees, we have to use a 3.142 pi value. Be careful. Many times it will come. Okay, so like this you have to calculate, you will get the 51.82 watts. Now a home electric heater draws 12 amperes when connected to 115 volts outlet. So the current is given 12 amperes and voltage is given 115 volts. How much energy consumed by the heater over a period of 24 hours? We have two types of equations here. Energy. What is it? Joule per second. Another watt hour. Means in one equation, same V into I only. The equation is V into I only. But joules per second, we have to convert this 24 hours into Thania. VIT. T should be in Thania, seconds. For joules per second. For watt hour, electrical quantity, what we call watt hour, we no need to convert this 24 hours into Thania. Okay, just multiply. So what is the equation? Power is equal to P VIT. P equal to VIT. What is V? 12. Sorry, 115. What is I? 12. What is the time? 24. Just observe further. Then you will get the 33.12 kilowatt hour. Means 33,120 watt hour. Kilo मौजूद है. Okay. Now if you want to convert into joule, multiply 60 into 60. It comes to Thania. Joules per second. Joules per second, Thania. So 60 is 3600. So 33120 multiplied by 3600 will give the joules per second. So like this, compute the power absorbed or supplied by each component of circuit. Same circuit what we have like previous one. P1, P2, P3 we can find. Then you can see here. What is the P1? From that minus 225. Minus 225 means power delivering, giving. What is P2? 90 watts taking. Plus 90 watts. P3 60 watts taking. P4 75 watts taking. Now sum up all the powers. Is it 225? 90 plus 60 plus 75. How much? 150 plus 75. 225. So minus 225 plus 225 equal to 0. So like this you have to calculate. Okay, a battery may be rated in an ampere hours. That's ampere hour. Means it's a ampere hour. It's a watt hour. Here ampere hour. For 1 hour it will give some amperes. Lead acid battery is rated 160 ampere hour. What is the maximum current can supply for 40 hours? So 160 divided by 40. We need ampere, right? That is ampere hour. 160 ampere hour. Come hours, Arbine hours. Taksim hour. So 160 by 40. So 4 amperes. By units only we can see that's ampere hour. Okay. Here hour is there. We need I, ampere. So hour must be cancelled. So it should be taksim. Mafi zar. Zar means hour square. So taksim. By units also we can be smart. Okay, how many days will it last if it is discharged at a rate of 1 milliamperes? So how many days it will take? You have to find 1 milliampere per second. Then how many days it will take to discharge completely? So we have to multiply how much? 160 ampere hour multiplied by 60 into 60. Then you will get the okay. That is what it will come for Tanya. Then divided by 24. Then you will get the 666.67 days. Days we need. Okay. So this is how we have to do this one.